All right. All right. So we're recording. All right. So welcome to Git uh, workshop about introduction to version control with Git and GitHub. We're going to jump into that in just a sec, but I just wanted to quickly take a look over this little survey that I had you fill out. Let's see what we got. I'm going to share my screen here so everybody can see it. All right. Are you folks online seeing my screen? Anyone see it? All right. So we have a little survey. I just wanted to ask to kind of see where everybody's at. What operating system do you use? Most folks are using Windows. We got one Linux user, which is great. Right now, the I'm using a Linux computer right now for this workshop. The cool thing about Git is it is cross-platform. Really, it's just a Linux program that is a command line program on Linux, and it's been ported to be used on Windows and Mac. So we'll see how that works in a bit. Which ones have you actually used? So we have about half the group has actually used Git before, but a lot of people are super familiar with or familiar with GitHub, which is great. There's a lot of code there. That's how people usually have encountered it. They're like trying to download something, and you get sent over to GitHub. So it's good to have that kind of literacy of what is the deal with Git and GitHub, and that's what we're going to do today. Some folks using Visual Studio Code, which is probably the most common text editor out there, but one of the things we're going to talk about is, I'm going to show you Git on the command line today, and that's just kind of to give you this really foundational experience of how it works. But ultimately, a lot of people don't use Git on the command line on a daily basis. They end up using it with visual tools like GitHub Desktop, and go ahead and take a seat wherever you like. Yeah. GitHub Desktop or something built into your editor, something like Visual Studio Code. And so there's a lot of different ways to use Git. We're going to go down to the fundamentals of using it on the command line, which is what it actually is, a command line program. But that's going to give you that kind of like understanding of what are the commands that it actually does. And then when you get out in your practice, you might not ever do that again. But at least you kind of have that literacy of understanding where it comes from. We have one person using some other version control system. There is other version control systems out there. Git has kind of won the version control battle in software. So that's what most folks are using these days. Have you used command line? We have the majority of folks coming in say that they've actually used it a bit, which is great. We have a few notes. This is going to be a little bit of an intro to the terminal for those who aren't super familiar with it. We're going to have to use a terminal to give some Git commands. So we're going to walk through that. There's not a whole lot that you're going to have to know about that, but it's good to just kind of get some of that experience as well. And what are some kind of use cases that folks are interested in? Python, R, kind of equally split there. Other types of code, collaborative writing. This is a use case that I actually use quite a bit. Writing papers in Markdown that we're going to use Pandoc or some other thing to convert into PDFs. Note taking is something I do every day. I do a lot of web projects, so web projects and GitHub Pages is my big kind of use case. Working with data, there's certain kinds of data that work really well in Git repositories, plain text, CSVs, things like that. There's some things that we don't want to put in Git, and we'll talk about that in a little bit more. Documentation, there's actually quite a few people interested in that, and that's cool. That's a really common way to contribute to open source software. It's not just about the code. You also can contribute with documentation, giving folks issues so that they know when things are broken, and all that kind of other ways that you can get collaborating on open source. So this is cool to see this from everyone. And I'm going to move this little thing out of my way. Close these guys. I'm going to close this. So on Zoom, can anyone just say that they're doing all right? Can you hear me okay?
It's great. Thank you.
All right, thank you. All right, so we're gonna get started here with this little outline is that I sent out. This link um, is the workshop. I write these so that you can use it as a kind of reference point. There is videos already on here from a 2021 version of this workshop, which I think is not a recorded in-person event. It was I just was reading it out in my office. So there's a lot more detail there that you can go into, but we'll try to get through this first bit of it and really just, like I said, trying to give you that firm introduction to what GitHub is, what Git is, how those things are different, and how we can use it to do some version control. So the first one is, if you're not familiar with XKCD, this is a really great comic series that has all kinds of tech and science type topics. And so it's like, this is Git, tracks collaborative work on projects through beautiful distributed graph theory tree model. Great, cool. How to use it? No idea. You just memorize these commands and type them. If you get errors, you just delete it all. And that's literally what I would suggest every time you get an error is don't get complicated. There's a lot of really bad advice out there when you search around to try to do complicated things. 99% of what you're going to do, unless you are working on a complicated software development team like the Linux kernel, you should just do the really basic commands and stick to that. If you ever get tempted to do something more complicated, just know that it's probably a bad decision, and you're better off just deleting it and starting over and getting a fresh copy from GitHub. So why are we interested in version control? The most common form of version control that you see in academics all the time is file naming. If you've ever worked with somebody on a document, and everybody keeps renaming it, and so you have like this example comic here where it's like final.doc, and then of course it's got to have a revision, so it's final revisions.to.doc, et cetera, and you end up with these ridiculous version control system that's based on those file names, and that's version control. Another example comic here is pretty classic too with the data. That's version control that's kind of local version control that depends on you doing a good job of organizing it so that you can avoid errors and be totally confused. But most likely in the end, you'll be completely confused. There's also the common one that folks in academics are going to use is track changes in a Word doc. The difference between track changes is it's really not a version control system at all. Once you accept a change in track changes, it deletes that history away and just makes that change. So you can't actually go back in track changes and understand what happened to that doc as it goes through. And then traditionally, a lot of software companies used centralized version control systems like SVN, where there's a central server that controls all the source code, and you have to check it out and check it in to do version control. And so Git is a little bit different than that. So a version control system is a system that's going to record the history of what the changes were made, who's made them, and then it's going to facilitate development and collaboration on that project. And are going to allow it to look at that history so we can understand the changes that happened over time, which is going to really help you be able to understand that history and debug it. So Git is a little bit different than those centralized version control systems. It's a distributed version control system, meaning that when you copy the file down to your local computer, the repository, you're going to have the complete history of that project on your local computer. And so it's not centralized in a server somewhere controlled by some particular person. You actually have a full copy of the entire history on your local machine. And that means that everybody can work on it locally. You can have all that history locally. It's very fast. We don't have to keep checking into a server somewhere. But then we use a platform like GitHub where we can push the central repository up called the remote, where we can keep syncing our histories back to that remote. And that's what enables us to do some really cool collaborative things. So originally Git was actually developed by the Linux kernel team to do this huge coordinated software development projects. So the Linux kernel is people who develop Linux, which is used on 99% of the computers in the world, because most computers are actually not your desktop computers, but they're servers and all kinds of other things. But so it's something that was designed for this huge software project, but it's actually really fast and flexible and simple enough that we can use it on any kind of size project. And it could be your personal notes, your lab notes, or it could be, giant software projects like that. When you're going to use Git, your project is actually just a folder of files. And that's something we're going to have to make sure we get in our heads. It's not something magic. It's just a folder of files on your computer or in the cloud somewhere on GitHub. And that folder of files is called a Git repository. And a lot of people will say repo for short. And like I said, Git is distributed, which means that every single copy of the repository contains the complete history, all the files that are stored in that history. So this is really good for the collaboration performance and using it offline. So rather than actually storing a whole bunch of different copies of those files with different file names or revision numbers and stuff like that, what Git is going to do is going to capture a complete snapshot of your project each time that you tell it to. And that when you tell it to is called taking a commit. So each commit is going to record who does it, your email, the time you did it, what changes were made, and then it stores all that away permanently in the history. So if we want to visualize what that's going to look like, we have a folder of files on your computer. So here's our file explorer. Here's my GitHub folder. Here's a folder of files here, Open Refine B, which is actually a Git repository, which is actually another one of these workshop websites. And you're going to see that there's a .git folder here. That is actually the Git repository, but this folder of files is the project that we're working on. So visually, we see all these files and folders that are in here, but there's this one hidden folder called .git. That's where the magic actually happens. And so we try to think about those changes recorded in each commit as actually kind of separate from the document itself. So from Git's point of view, the current file that you see in your folder is actually made up of a set of changes. So you can reconstruct all the different versions by jumping through your commits, and the complete history is safely stored in this little hidden folder called .git. And so this file here that we're visually seeing is the one that we can edit and do stuff with, but we actually have all the changes that have happened to it over time stored secretly in this little database that's hidden away. So your first version looks like this. You make some changes, and these changes are essentially what gets stored in that history rather than a full copy of that document. The upside of that being that you can do all kinds of interesting things, like have different branches that are parallel, where you do different sets of changes. So we have this document, create a new branch, add some changes here, but somebody else, Mary Elizabeth here, is doing some different changes. So she created a different branch, added some different changes. And then at a certain point, we're like, oh, hey, we should put those together because they're both really good new sentences or features. We can actually, Git allows us to merge those changes back together, essentially because those changes are separate from the document itself. So whenever you add a commit, it's only adding data to your history. It's never deleting information from your history, which means that almost anything is undoable, or at least you could go figure out what the deal was with the history. And so the whole idea of Git and having this version controlling and being able to do branches is that you should be really brave, be able to make changes, explore, experiment with your code and writing or whatever else, and do interesting things. So that's where we're trying to get to. The last thing we want to make sure that folks are aware of and understand at this point is that what Git is good at, it's designed for tracking plain text files. So there's really kind of two types of files in the world. There's binary files. Those are like images, videos, Word files. Binary files require some piece of software to interpret the bits into whatever they're supposed to be representing. So if you want to look at a video or an image, you need an image viewer. If you want to look at a video, you need a video viewer. The bits in there are encoded in a specific encoding style that is based on that viewer. And binary files is not what Git is designed to track. What Git is designed to track is plain text files. So in a plain text file, that would be Python files, R files, HTML, Markdown, .txt. Any kind of code is usually a plain text file. Plain text files, every bit inside of that file is actually representing a character. So it's going to represent a G, an I, a T, a space, all the plain text characters that exist in the universe. And so Git is really designed to work with plain text files. It knows if an image file has changed, but it can't tell you exactly what has changed in that file because the binary is one blob. It knows when a plain text file changes, it can tell you exactly which characters have changed. So really, it's not designed to be tracking your images and videos and things like that. And those will also very quickly bloat your history, because to understand the difference between changes, it actually has to store a whole nother copy of the image over and over again. And so it's really not optimized for doing work with those kind of formats, PDFs, images, videos, docx. Those really shouldn't be in there to track the changes of. What you want in there is your Python files, your R files, HTML, Markdown, .csvs, TSVs, JSON, XML, YAML, other things that are plain text files based. So that's something to just keep in mind. This might impact some of your choices that you might want to actually use plain text for writing, like say Markdown or LaTeX, which really works really well in Git and also works well in general in your workflows. So what we're going to do is just we're going to start on GitHub today and do a couple things on GitHub. And then we're going to jump down to our local machine and do a little bit, taking that GitHub repository down to our local machine and then do a little bit of editing there. So the idea is really, again, this is just going to introduce you to the basics, introduce you to the fundamentals. And then the only way that you can really learn and start to understand Git is to repeat it, do it a whole bunch of times, actually have a meaningful project that you're going to work on. So hopefully this gets you enough of a literacy that you can jump in on something that'll be meaningful to you. So we've been talking about Git, which is that version control system, right? And the version control system, Git, is a piece of software. You install it on your computer. GitHub is something actually different. GitHub is a web service for hosting Git repositories. So it's basically your Google Drive that is specifically for Git repositories. So it's a place to store, sync your work in the cloud, and also create this web interface for collaborating with other people or collaborating with yourself. So GitHub is really useful because you put your repositories in there and you can sync them between your different computers or different people's computers. And then, but it has all these project management, collaboration features that are in there that are making it really useful. So GitHub is probably the most popular. It's not the only one. There is a lot of other alternatives out there, but I'm just using GitHub because it's the one that most people are going to encounter. And if you want to kind of have a presence in open source, it's a great place to put your stuff because it's just the most popular. People get there and people can find stuff on that site. It's just really important to keep in mind that Git, that version control system, is a piece of software. GitHub is actually different. It's a web hosting platform. And so it's easy to get those things kind of conflated. And I just want to make that really clear from the start. So what we're going to do is go over and check out GitHub. And so if you have an account, you're going to head over there right now. Your account, if you haven't used it for a while, is probably doesn't look so complicated as mine. I have a bunch of repositories here. I have this kind of stream of people that I'm following or projects that I'm involved in, so that I'm getting these updates of all the things happening. And then on this side is a bunch of kind of advertisements from GitHub about things that it thinks I should be interested in. But this is, if you're logged in, this is what it's going to look like. And so you want to get logged in. Everybody should get logged in here. This is a hands-on kind of workshop. We're gonna do some stuff here and get started with it. So
do I have to?
Yeah, so if you go to github.com, you will be there, and you got to log in if you're not logged in already. Did you get emails from me earlier?
Yeah.
Okay, yeah. All right. So the outline for the workshop is going to be helpful to just grab all the links from that, and so you can follow along there. And I emailed that out to everybody earlier, or you could email it to somebody. All right, you all right? You got somewhere? Anybody have questions, big picture questions about what's going on before we start doing something on GitHub here? Feel free to talk online or jump in the chat. Big picture questions in person here. Okay. So typically you can start on your local machine and create a repository from scratch on your local machine and then push it onto GitHub, but that's a workflow that's much harder than necessary and is really rare. You're never really going to do that. So more typically would be that you'll have a repository on GitHub that you're going to work on or collaborate with other people on, and then you're going to clone a copy of that down to your local machine. So that's kind of what we're going to set up here. Is we're going to set up a test repository on GitHub, show you around GitHub for a bit, and then we're going to clone that down to our local machine. And we'll talk about that more in a bit. But what we're going to do here is first create a new repository. So you're going to go over to GitHub. You're going to be logged in. So I'm logged in. I can see my little account here. And then up here in the upper right-hand corner, you're going to see all of your kind of stuff. And there's a big plus button, and you're going to click that plus button. And you're going to look for new repository. So you're going to just click that new repository button, which is going to be the first step for creating a new repository. So repository, like I said, is going to be a folder of files. And so you're going to have basically one repository for every kind of project that you're working on. It's going to be all the files that are interrelated to a specific project. A lot of times that would be, say, like a website or a coding project, maybe like a specific Python app, or so maybe sometimes I'll be like, I'm exploring some ideas in Python, and I'll just have a repository that has a bunch of different little Python scripts in it. So you kind of group things together. You're not going to have everything into one repository. It's going to be kind of topical. It's going to open up this little form, and the owner is going to be you. If you are part of an organization, you can have organization accounts, which I would suggest setting up if you're collaborating with people. You can change the owner to the organization rather than to you, and that'll enable it so that your repository will kind of be owned outside of any single individual, meaning that, like, if you have a research lab, you might have all of your research folks in that organization. So if anyone comes and goes, you still maintain all the repositories that the lab kind of created without having to like figure out what individual actually owned it. And so that's a really helpful thing to know. You're going to give your repository a name. And so this is going to be just that folder, that the name of the folder. So I always use underscore, lowercase, and no spaces, no weird characters, and maybe underscores and dashes rather than spaces. I think that just makes it a lot easier to work with folders in general. So that would be the best practice for file name. So I'm going to do one that's like example repo today. So it just has to be unique to that organization or to your personal account, because again, it's going to be a folder of files, essentially in your account, whoever the owner is. You can give it a description if you want. You can make it public or private. 99% of the stuff is public. I would just leave it public because this is a test and no one cares. No one's stalking you and being like, why are you creating weird repositories? And you can always delete it. So I would just leave it public. I would check this box that says add a README file. That's just going to add one file into our repository so that we have something to get started with. So I always check that if you're starting a new repository. And then you can ignore the rest of this. But these are just some kind of helpers to try to get you started with some boilerplate stuff, but we don't really need it. Down here at the bottom, we have a big button that says create repository. And you'll see that in GitHub, most things that are good are green. So we're going to click that, create the repository to finish off generating this demo repository. And again, don't worry about like this is just for testing. Part of the whole fun and empowerment of this platform is the ability to just create things and then delete them. So this is the best way to learn: is create something, mess around with it, go ahead and delete it later, or keep it forever if you want. Doesn't matter. It's all free at this point. And I think I mentioned it in the instructions to set up account, but you don't need any of the paid add-ons at all. It's free at this point for what you need to do. In the past, it was always that public repositories were free and you had to pay to be private, and they kind of changed that. So actually, you can have private ones now for free as well. But just so you know, the public ones in particular are always free. All right, so now we have this new repository. This is going to be the home for our project. And just going to zoom in a bit here. All right. And what we're looking at here is the repository homepage. And so you can see at the top left here, the owner of the repository is always here. And then next is the name of that repository. So it's kind of like a file system. So it's basically a folder of files, right? Next below that, you're going to see a series of tabs that are the GitHub kind of added features to this repository. The code tab is the main one that just shows us the code, the file, the folder of files that we have. Right now, we just have one folder. We only have one file in our folder right here, which is readme.md. And then we have a couple other tabs here that we'll talk more about as we go, but just for a preview of kind of like the project management stuff here on GitHub, there's this issues tab. This is where there's essentially little tracker, so you can create a new issue. You just say here, you give it a title like it's like a to-do list usually. Edit the README, and then you just say what you want to do. You should edit it, and then you can also put little check boxes in here, like, and then I'm going to submit that issue with the green. And what that does is it adds this little request onto my issues page. And this is really great for project management because we can set these tasks. We could assign it to somebody in our group, assign it to myself. And so it's really just a project management tool or communication tool for your project. A lot of times, if you're visiting some major software project, these issues are tracking very specific things that need to get fixed, bugs or new features. So if you're going to, like, say, the Open or Find site and you had a bug that you've encountered, you can create an issue to report it to them so they understand what problems people are encountering. So there's a kind of a lot of different uses for this, but on your own personal projects, a lot of times these issues are just kind of project management. So now I can check off these little things that I did if I did them, and then I can close that issue when it's complete. And it's really satisfying to close out issues, fix those bugs. And then it's also a public kind of forum, so other people can come in here and comment. You can tag other people onto it. So in this one, it just has tagging me, but you can tag @mention people on your team, people you collaborate with, so that you can kind of use this as a really strong project management feature. If you ever need to delete your repository, you're going to go over here to the settings tab, and you're going to scroll down to the bottom here, and it's going to give you these danger zone, these red things, allow you to make it public or private. It allows you to transfer the ownership to somebody else. It allows you to archive it, which means you're going to keep it, but it's going to be read only, or it allows you to delete the repository. So if you ever want to delete it, settings tab, scroll to the bottom here, there's delete, just to get you orientated there right away. So let's go back. Let's click that code tab, get back to the home page of our repository. The thing that you're going to see right away is that we have this little representation here of what's in our folder, which is one file. And then they always, by default, display the README file. So README is a convention in code in general, and specifically in GitHub. If you put a readme.md or .txt into that folder, it's going to display there, and it's just a place where you're going to describe this project for other people or for yourself, reminders to your future self what this is. And so it's just a really a conventional kind of file that is important to make sure that you kind of like put the essential information and description about what this code, what this project is. And so what we want to do is go ahead and edit that README file here on the web editor. So you can get there by clicking on this README file in that display. You're going to be here. If we had more than one file, it would show kind of a file explorer here, but it's displaying a preview of that markdown code because markdown can be rendered to HTML for us. But if you have other types of code, it'll try to show it like with some syntax highlighting and stuff like that. And if we want to edit that on GitHub, there's this little pencil icon right here in the upper right-hand side of the file preview. So there's a pencil icon. We're going to edit that file. And it's going to open up a little text editor right here in the browser. And you can see that this is some markdown. Markdown, we just do headers, that bigger text, by having a hash space and some text. So it has the name of the repository automatically in there. I'm going to press enter after that and enter again to just put a blank line. Then I'm just going to start writing, and I'm going to say, this is an example test project for a workshop. Okay, so just going to write some kind of text in there, right? Whatever you want to write. I like to put a blank line. I press enter and put a blank line after that one. This is just convention, but this is Markdown. You can learn more about how to write Markdown. You can use Markdown in Markdown files, .md files. You can also use it in all the issues and pull requests and other kinds of conversations that happen on GitHub. Okay, so we've made some changes here, right? But it's not saved. It's not committed into the repository yet. So that's the next step. We need to actually make these little changes that we did part of the history of this repository. And so we have this button up here that's green that says commit changes. So it doesn't say save, it says commit. We're going to click commit changes. And I told you earlier that when you commit into your history, it's going to record a person, a time, the changes you made, and a message about that commit. So you are required to give a message what you did. And so this little form shows up. You can see it's already captured me. I'm the one doing it. I could switch to somebody else if I wanted to, if you have multiple accounts. It's going to ask you for a message, and it's pre-filled it in for me, or for you and me, with what it thinks you might want the message to be. But let's go ahead and write a commit message. So commit message is a really brief, condensed summary of what you just did. So you want it to be understandable. This is like a love letter to your future self, to your collaborators, telling them what you did, why you did it, in a really condensed kind of way. So I might say that. If you needed to elaborate longer than one small line, you're welcome to enter into this extended description, and that's where sometimes you might describe a little bit more detail if it's something that's more complicated that you really want to remember what you were doing at that point in time. You can add some more description into that extended description. So if we wrote some, I wouldn't normally do this, obviously, because it's not very complicated, on new lines. If there was some reason that you wanted to make a note for yourself, make sure that you understood in the future what was going on, you can use that extended description. And then you're going to commit the changes with this green button. So we're going to click commit changes, and bam, we have this new file. If we go back here to the code tab, our home page here, we're going to see that actually we have some history now in our repository. So you can see if we look on this home page again, click code, there's this first little line here is actually the most recent commit is being displayed. And if we click on this little button right here where it says 2 commits, so on the right-hand side of this commit message, we're going to see the history. Now, this is the history so far in this repository. History is always linear. It's builds on top of each other. So you can't really go off and do other things. It's always in a straight row. Even if we undid this commit, the undo would be another commit on top of it. It wouldn't undo, it wouldn't delete this commit ever. It would be adding another commit that says undoing that last commit. So that's important to understand, is that the history is always linear. We never delete anything from the history. We just change it. And so we can see in this list of commits on GitHub, it's given us a nice way to kind of visualize that. The person who did it, when they did it, their commit message, and then right here we'll see a little number, and that's called the hash. So every single commit in your repository is represented and stored by a unique identifier called the hash. And if we click on that hash, we'll actually see what changes happened. So now we're into a little page that's representing this exact commit that I just did. It's showing me that little short description, my longer description, who did it, when they did it. And then below that, we're actually seeing the details of exactly what was done. And this is called a diff. And so this is a representation of the changes. And so the diff, we see red as lines that were deleted and green as lines that are added. So anything that is changed is considered added to. So in this case, it thinks that we deleted a line and then we added 3 new lines. I must have added a space at the end of that title or something. So it thinks that something actually changed there. But we can see, we'll be able to see in more complicated examples where changes have happened in a more complicated way. So I can give you some examples here. Here's the main web design draft project, which is the project that actually builds our library website. So this website here is maintained in this repository. And if we look at the history, there's 4,300 commits, so it's been going on for a long time. We can see when something happens, who did it, and then we can go and take a look at the commit details. We can see exactly what sort of things were changed with those details. So this line was deleted, this green one was added, replacing what happened in that line. There was this little bit of content that was deleted, and some new content was put in its place. The other interesting things that you can build up once you have a lot of commits and stuff going on is on this Insights tab, we can actually analyze the commits and get a lot of data about what's happened over time. And so if I click on, this is my main web design draft, Insights, contributors, it's going to crunch the data apparently, and it'll let us know, what's happened over time in this repository. And you can see that it started back in 2019. We did a whole bunch of work on it, and then we've done a lot of little bits of work. And then in the summer of 2020, it looks like we did a whole overhaul, bunch of little work. And so you can see kind of what happens in your repository over time. And then you can see all the different people who are involved. So there's me and another librarian, Jaleesa, Olivia, another librarian, Devin, a librarian. And so there's a lot of people who have contributed to this project over time, which is really neat. You get to see how that happens. So that's what we're going to be able to do with your history. A lot of times your projects aren't that complicated, and you don't worry about it. A lot of times, 90% of my repositories are collaborating with myself and my future self. The cool thing about having that history is that you can go back to it 3 months from now and try to figure out what was I doing? What was I stuck on? You actually have a record there telling you what you were doing. So for me, that's the number one use case, is actually collaborating with myself. Okay, so we've edited the README with the .md, which is the markdown. Let's go ahead and add one more file in here just so that we can have something to work with before we bring it to our local machine. So to add another file on the GitHub interface, we're going to go to that code tab again, which is our homepage. There's this little button here that says add file, create new file. And this is just going to create a plain text file. of any kind that you'd like. And so in this case, we're going to create another one that's just, we're going to call it example.md. So it's going to be another markdown file. So it's showing you this is the folder that it's in, which is the repository name. This is the file name that we're putting in here. If you wanted to put it into a folder, you can actually create the folders here too in this little editor by just putting the name and then slash and then the file name, and it'll actually create that folder for you. But I'm just going to leave it as example.md. It's given us this little editor window where we can start creating a file. And I'm just going to do hash space example to give a markdown title, leave a blank line, and then just put some random stuff in there. Whatever you want to say. Okay, great.
Sorry, got lost.
Sure. You want me to just walk through that little bit again?
Yes.
All right. So let me complete this one, and then I'll roll through that whole thing again. So we went to the code tab. There was a button there. I'll flip over that. So if you're on your repository, you go to code tab, which is the homepage for your repository. There's a button that says add a file. Click on that and say create new file. That's going to open up this little editor, which is a little visual editor for us to create a new file. You have to give your file a file name up here. So this is the name of the folder, which is the repository name. You're going to add a file name like example.md, which would be a markdown file. And then this is a plain text file. We're just going to add some content in there. Doesn't matter too much what it is, but I just put in some markdown. So I put a hash space to create a title, left a blank line under it, and then wrote some random text on that file. Anybody know what we do next? Do we save it? We're going to commit it. All right. So we got to commit the changes. That's the green button up here in the upper right hand of this little editor. We're going to commit those changes by clicking the green button. It's going to bring up this little form again. And in this form, we got to give a message. It's already filled in the message for us, but we can say what we want. Future note to yourself that helps you understand what you were doing. This stuff we just leave where it is because we don't need to change any of that. Green button commits those changes. We haven't saved this into the history until we click that button. So if we click that, we will have committed that. Now, if I go back to my home page, we're going to see that now we have 2 files in our repository. Our README is still displayed down here. So everybody go through that? Okay. All right, so congratulations, you're a Git user now. We've been doing some Git commits on GitHub if you haven't done that before. One other thing I just want to show you here as a preview on GitHub that's kind of cool is if you are in any repository on GitHub, but most likely the ones that you own, if you click period, the period button on your keyboard, click that, it actually is going to open up a web version of Visual Studio Code. So this is a little text editor integrated development environment that's going to make it easier for you to actually work on this project on the web. So again, we could just use this if we didn't want to install anything on our local machine at all. We could still do, quite a bit of work here using this Visual Studio Code on this web browser without installing anything. So it's kind of a cool feature that's there if you're interested and if you're familiar with Visual Studio Code. This is exactly the same thing, just doesn't have direct access to your local machine, so you won't be able to run a terminal or run code and stuff on it unless you set up code spaces and all that kind of stuff, which is beyond this workshop. So if you're here at this Visual Studio Code version of it, to get back to your repository, you click this little hamburger button and it says go to the repository. I'm going to click that go to the repository to get back to where I was. And now I'm back at my repository. All right, so we viewed the history. I showed you issues, insights, the settings tab, how to delete stuff. I showed you that built-in editor. And there's a lot more to learn about GitHub and what you can do with it. So there's some resources here on the outline if you ever want to go back and learn some more. And there's also, it wouldn't take you long to learn about Markdown. Markdown could be used all over the place on GitHub for writing and communicating. So that's our little whirlwind of GitHub, I mean. And the next step that we want to do is actually do this version control on our local machine so that we're actually using Git directly at this point in time. So any questions on GitHub that anyone has out there in the class or online or in person here? Questions about GitHub in general? So it's pretty user friendly once you kind of there's an intimidation factor to folks who haven't ever seen this before when they get here, and it just kind of looks weird, don't really understand what it is, but it's not too hard to use once you kind of get used to that and get over that intimidation factor. And there's a lot of great things here for collaboration that are really applicable to work in academics. So you're going to see that I did that editing of that README, which was my issue that I opened here for myself. So I'm going to go over there and take a look at it, edit the README. Oh, I did it. So now I can close this issue off. So that's kind of nice. Now no issues in my repository. We've done some tasks. It's really satisfying to click close those issues. So that's just something that's fun. Okay, so now what we want to do is do Git on our local machine, see what that looks like on our computers. That's going to be where you're actually doing this work. You need Git installed. Hopefully all you folks have got that sorted out. It's usually not too difficult. And then the next thing that we're going to have to do is that we have to open a terminal. And so the terminal is a little way to interact directly with your computer on what we call a command line. And there's different types of terminals. That's one thing to be aware of. And so on Windows, there's a built-in terminal called PowerShell or CMD, and we can't use that for Git. Git doesn't work at all with that. And so on Windows, what Git has done is it's packaged this little emulator of a Linux-style environment, and that little emulator is called Git Bash. So if you're on Windows, what you're going to do is click your Windows button, and you're going to search for Git Bash and open it. And that's going to get you a terminal that looks like this one here. And if you're on Mac, you're going to open your Finder, which is like, or your Spotlight search, and you're going to search for terminal, and you'll get a terminal that comes up, and it's going to look something like this. And I'm on Linux, you're going to search for terminal like this, and you're going to get a terminal. And everybody have a terminal?
I have a question.
Go ahead.
On Windows, could you not just add the path to system variables to make it work in CMD?
No, because Git is all written with Linux file paths and a bunch of Linux utilities, and Windows doesn't have all of those built in. So the big difference, well, the file paths is something that comes up a lot, is that Windows has file paths that go like this, Linux and the rest of the world does it like this. And so that ends up causing just like some really simple but fundamental problems. But then there's all these utilities that are necessary, like the hashing algorithms and the little database that they install. And so what they did, rather than try to like port it to PowerShell, is to just create this little environment. There is, if you go through that Git for Windows installer, there is an option to say make it available in PowerShell and CMD, but it tends to result in weird things happening. So I don't generally suggest doing it. And then the one thing to keep in mind too is that in the end, like I think Git Bash is really great on Windows because you can do some other things that you wouldn't normally get to do because of the little things that they packaged with it. But in the end, a lot of people are going to be using not the command line in most of the cases when they're using Git. But this is the official way that you actually use it. And so we'll see that in a moment too. But that's a good question. Thanks. Okay, so everybody have a terminal open? Successfully found that. So your terminals are all going to look something like this. And what you see in your terminal, and I'll just show this Git bash version here too, is some stuff, a little blinking cursor, and so this is your name, and it's going to say @ and then it's going to say the computer's name. In this Git bash, it's going to say minwing64, which is its little emulator thing. And then it's going to give you a location. Where is this terminal currently located in your file system? And so on mine, I've got my name and my computer's name, and it's saying NA, which means your home directory. And then it has this little prompt and a place where we can start typing random stuff. I don't actually want to give that command because it's a bunch of random stuff. So what I want to do is do Control-C, which means cancel that. No matter where you are in the command line, Control-C should stop whatever's happening or cancel that command from going in there. So random stuff, Control-C, I stopped it. Okay, we're not going to do that. And what we need to do is make sure that our Git is correctly set up. And this may, on Windows, already be done for you. And depending on how you have your Mac set up, it might be done already. But to get set up, we're going to have to do this just one time when you set up Git on your local machine. And sometimes if you've installed GitHub Desktop, it's actually set it up differently on somewhere else, but it hasn't set it up on the command line, so you still might have to do this. And so we're going to need to follow these little set of commands. And you're just doing this first time on this computer, and if you install it again on a different computer. We need to tell Git who we are, because I told you we've got to record our name every time we make a command. So on the command line, what we do is we tell it the program that we want to access. So we want to access Git. We're going to give that program some commands. And so the command here is config. And then we can add some sort of qualifiers, some arguments to that command. And so the arguments here, we're going to say -- global, which is called a flag, which means we're going to apply this to everything on our configuration, space, user.name. That's essentially a value in a database. So we're going to set the user.name, and you're going to have to set a name in there. So the name that I would put there would be your GitHub username, is typically what I would do, but you can actually use whatever name you want, like your regular name. But that name is going to show up in your history. So I would usually just make it, my GitHub username is Evan Will, so I typically make it Evan Will. And then to run that command, you're going to press Enter. I'm not going to do that because I'm already configured, but I could check that by saying git config user.name. See, I didn't give it this global tag and I didn't say anything after that. And I press Enter and it's going to tell me what I'm currently set at. And it's currently set at Evan Will for me. So you might want to just check that first. Git space config space user.name. Press return, and it's going to tell you if you have something set. And if you don't, you're going to make sure you do this command that's here in the outline to make sure that you set a name, because you need one. You're going to do the same thing. We need to also set your email. So we're going to do git config user.email. And you can check that first to see if you have one set, but you need an email set. You can't commit until you have an email set. And so you can press return, and you'll see what your email is set at. And if you don't have one set, you're going to have to give this command here, git config -- global user.email, and then put your email in quotes. Go ahead and question in here. Let's see what you have. Oh, yep, you just, that second time there, you just spelled it. The first time, you want to have a space after username here, and then this time it's just spelled wrong, so you're going to have to just respell it.
Yes, mine is not liking the symbol for what you call it. Is it for the index?
So you don't have one set yet. So git config full space, put a quote, and then type your email there, and then put a quote at the end of it.
Oh, sure.
So make sure if you put quotes around your email that you put a quote, your email that the email that you want to use is the one that matches your GitHub account. That's important. Sorry, I didn't mention that. And then put a quote at the end. If you don't put a quote at the end, it won't stop that. And then press enter. Let's see what you got. Yeah, you got it. Great.
Thanks.
You got it. You're set, or you? Folks online, are you successfully getting configured? Anyone want to chime in?
Yes, thanks.
Getting a couple plus or thumbs. That's good. So this is just something that you're going to do one time on a computer once you freshly install. It's important to understand that when you commit, you are going to have your email in that history. So if your repository is in the public, your email will be in the public. You can see that that's kind of, it's not immediately available here, but if I dug into it, I could figure out what the person's email is. Most people just use a kind of professional email, and I've never had any problem with it myself. But there is the option to essentially set up a kind of proxy email on GitHub so that it maintains your privacy. And so that's something that is definitely worth thinking about. You just need to remember that you always use that proxy email when you configure. Otherwise, you'll end up accidentally exposing your email. So if you get done with this class later and you think about it and you're like, yeah, I should do that, just make sure you go and change your config to your proxy email that you set up with GitHub. And if you do that, the last thing that you might want to do is that if you're on Windows, you follow the instructions that I sent, you hopefully have the editor Nano configured. But if you're not on Windows, you probably have Vim configured as your default editor. This is only going to come out in a few cases where if you forget to give a message, or if you have a merge commit that kind of happens automatically, it's going to open up, because you have to have a message with a commit, it's going to open up an editor and ask you to enter a message. That editor by default is Vim, which is a super confusing command line editor. If you're not familiar with it, a lot of people really love it if they are familiar with it. But if you're not familiar, it's going to be very confusing. And so I usually suggest to change that configuration to Nano if you're on Mac and Linux. And on Windows, you have the choice while you are doing that install process. And so hopefully you've selected Nano there, so you won't have to do this manually. But if you haven't, you can run this command to configure it to Nano. This isn't going to come up today, but just something to be aware of if you haven't done that in the past. Okay, so we've configured our GitHub on the command line, or our Git on the command line, and I'm going to the next thing that we need to do is we want to take this little folder of files that we have up here on GitHub, and we want to get it down to our local machine. And so in Git, that's called cloning a repository. And then this version that's on GitHub is what we call the remote. So to clone the repository is going to be a Git command. But first, we want to clone it into the place that we actually want this repository to be. And that's actually a pretty important thing to keep in consideration now with the way that most of the Windows 11 is configured, where everything is in OneDrive. You don't want it in OneDrive. You don't want it in your Google Drive, because you're going to be syncing up already to GitHub. You don't need another sync of it into some other platform. And it's going to end up, because of all of the little database stuff that's generated by it, it's going to end up using a lot of your bandwidth on your OneDrive, which is going to waste your CPU, essentially, especially if you're doing a web project. And so what you want to do is try to figure out how to navigate to a folder that is not in one of your automatically syncing drives. On Windows, they don't make it super obvious. A lot of, or on Windows 11, it seems that it's configured to like your documents is now actually a OneDrive folder. So what you want to do on Windows is go down to C, username or username documents, which is the one that's actually on your hard drive versus the one that's on your hard drive but synced to OneDrive. So just keep that in mind. It's not going to be a problem today, but it's important to think about the file system when you're working with Git, because a lot of our computers nowadays are kind of set up in a way that tries to make it confusing to work with a file system. But this is a file system kind of program. So what you're going to want to do is we could, just open our terminal and then navigate over to where we want to go. So I could go CD, documents, etc., and navigate over there. We don't need to do that today. What we're going to do is a shortcut. Is you want to open up your folder, your file explorer on Windows. I can't remember what it's called on Mac, but we'll just call it File Explorer. This thing that shows your files. And then you want to go to your documents, probably. And then I usually would set up a place where I'm going to put all my GitHub repositories. So personally, I created a folder called GitHub. And so you would just create a new folder for this. So I'm just going to create a test one just for fun. Doesn't matter what it's called. So I'm going to say example folder. I'm just going to use that one for today. So I have this one called example folder. In my real practice, I keep one called GitHub. Inside my GitHub folder, I actually set up different, because I'm part of a bunch of organizations, and so I have my personal one, and then I have all these different organizations. That just helps me stay organized. You can do whatever you want. In this example folder that we have on my File Explorer, you're going to right-click, two-finger click, right-click, and you want to open it in Terminal. So you're going to have that option on Mac and on Linux, and on Windows, what you want to look for is open in Git Bash. And on Windows 11, I think that it actually hides it in a More menu. So if anyone on Windows 11 could confirm to me if they can find it, you should be able to find open in Git Bash. And that should open a terminal. I'm going to take a look at around the table here with folks. Oh, on Mac.
At the very bottom, new terminal folder.
Oh, you have like two-finger click. Oh, okay. Open new terminal at the folder. So I'm looking at an older Mac. They had to physically two-finger click, push down to two-finger click, and then it says open new terminal at location or at folder. Yeah, new terminal at folder. So open new terminal at folder on the Mac. You folks got? All right. And are you Windows 11 or you guys 11 or all 10? Oh, you're on a Mac. Okay, sorry. Yeah. Okay. So we're on our terminal, and now if we take a look at our terminal, like I said, the terminal has to be in a location on our computer. So if I make mine huge, which I guess I'll do, super confusing now. You're going to see, here's my username, my computer's name, and now we have this file location here. So I'm in my home directory, I'm in the documents folder, and I'm in this example folder. So I have a location in the file system where I'm at. So that corresponds to this folder here. It's in here, is where it's at. And what I want to do is I'm going to make a copy of this repository into this folder. And so how I do that is cloning. And so we're going to go back to GitHub. A big old green button, as usual on GitHub, is good things. We're going to click the button that says code, and it's going to offer us some options here. And we just want HTTPS. There's a URL right here, and you're just going to click the little copy to the clipboard button. That's going to copy it into your clipboard. If you have GitHub Desktop installed, it will also have options here that are like open with GitHub Desktop. And you can do that in your normal practice, but today we're just going to do it by cloning instead. If you ever want to get a repository that does not have the Git history in it, you just want the files out of it, which is a lot of times, sometimes you want that. If you're grabbing somebody else's project, you don't care about the history. You can click this one that says download the zip. That's just going to get you the files, not the history. In this case, cloning makes sure that we maintain a connection between this version on GitHub and the one that's going to be down on our local machine. So I'm just going to walk through that again. Green button that says code, click it, clone HTTPS. Here's the URL, and I click the little copy to the clipboard to get that in my clipboard. Now we go over here to our terminal. We got to give it a command. I think I'll make this smaller again since it's kind of centered. The piece of software that we want to use is what we say first. So we say git space, that's a piece of software. The command we want to give it is clone space. And then clone, we need to give it an argument what we want to clone, and you're going to paste in that URL. And so you're going to do that with a 2-finger click in there and paste. Or you can do Control-Shift-V. We'll paste it in there. And you just need to get that URL into that command. Everybody successfully paste that in there? All right. And then you're going to press Enter to give that command to your terminal. We're going to get some feedback from Git. It's saying, okay, we're going to clone it. It goes up to the remote. That remote is the GitHub version. It's going to take down some objects and unpack it. So it's doing this in a very optimized kind of way, which is pretty good. And you can see now in my folder, my example folder, I now have a folder, which is my example repo today. So if it goes up here, that's what this is, right? I have a folder of files here. I now have a folder of files on my local machine. If I go in there, I can see 3 things. Now, right now I have show hidden files enabled. So you might only see 2 things, which are those 2 files right here. If you're on Windows and Mac, I would suggest to make sure that your file explorer is configured to show extensions. It's really important to know what the file extensions are. And then you can also configure it to show hidden files. So I'm going to show hidden files. And we see that .git file. And so .git, if you have a dot in front of a folder name, by default, your file explorer is going to hide that from you. You don't ever want to edit this .git file, okay? It's hidden for a reason, because you don't mess with it. That is actually the Git repository. That is where the history is actually stored inside this .git file. So this is what has our full history of what's happening. If you want to get rid of your history and get rid of this being a Git repository, the difference between a regular folder of files and a Git repository is that it has this .git folder in it. So if I didn't want this to be a Git repository anymore, literally I could just delete that. Now it's a regular folder of files. It's regular folder of files anyway, but that's if you ever wanted to destruct it for some reason. So I have a folder of files. I got 2 things in it. Same thing as what I have up here, 2 things in it. Any questions on cloning? Did everybody successfully get it?
It says done. It's not.
So let's see. Oh, you did it in. Let's see. Sorry. Yeah, so it's in your home rather than the location where you tried to open it, I guess.
Okay.
So you're gonna have to go back to your. It's actually in your home directory. I don't put there on Mac. Do you know how to make the file explorer in Mac to go back to your home directory?
You should be able to just go to the locations, and then you should be able to find the hard drive at the bottom. And then on your users folder.
Locations.
So online questions about cloning from anyone? Cloning over here good?
Yeah.
All right. Find your files.
computer.
So file system is something that like is a fundamental of computing, but is kind of like all of our software nowadays is super helpful and kind of hides the file system from you. And so that can cause a lot of issues when you're working with code, working with version control, obviously, and working in projects in general. It's a kind of literacy that I like to teach with our undergrad students a lot, just because it is something that is really kind of mystified in today's computing kind of environment.
Probably just reclone it down to the correct spot.
Yeah, that's probably good. Thanks.
So I'm realizing that at Mac GitHub, when trying to download some of these codes and cloned before, but I've not tried to create my own.
Do your own repository. Yeah, yeah. So yeah, like
It's making sense.
yeah, yeah. So that's part of like is just yeah, that's probably the first use of GitHub. You're like, somebody gives you this link and you're like, get this piece of software, and you're like, okay, a little bit confusing. But so hopefully that's part of this is just being able to like be a little bit more aware of that. All right. Hopefully everybody's hanging in there. We've brought a copy of our remote down to our local machine, and now we get to work with it. So I want to just cover exactly what the usual routine is on Git. The first thing is this is a distributed version control system, so we need a copy of the history on our local machine. And so that's what we just did. We did git clone. Now you're only going to do that one time on your local computer. You don't need to clone it every time. You're just going to clone it one time. Now we have that folder on our machine. It's already magically configured to be connected to that remote. So I don't have to configure that or anything. It's in my folder in my file explorer where I put it. And we have a full copy of that history. To make a connection between our local and our remote is not automatic. It doesn't hop in automatically. It doesn't sync in the background. It only syncs when we tell it to sync. Okay, that's important because Git is kind of local first. You're doing stuff locally. If you actually want all the stuff you did locally to show up on the remote, you have to tell it that you want it to go up to the remote. So we'll see that in a little bit, but it's just something to keep in mind. And so the steps that we're going to have to do as we edit files is we're going to do a git add, git commit, which is putting that into the history, and then git push, which is take the stuff that we did locally and put it up onto GitHub. And we'll repeat that over and over and over again. That's what we do. And so to try to make sense of that, I have this little this image that makes sense of it. It'll make more sense as we go forward. So we'll kind of probably refer back to that a little bit in a little bit later. So we did this git cloning. The first thing that we want to do is, okay, I did that git clone. My terminal is still open. If you typed in right now git status, you're going to get an error. So we git space status would be, tell me what's up with this repository. And it's going to give us an error because we aren't actually in that repository right now. We're actually in the folder where we just made a copy of the repository. So the first thing that we want to do is get into that repository. And so we can do that on the command line by just saying cd space, and then we're going to start typing the repository's name. So I'm going to say X, my repository is called example repo today, and I'm just start doing EX, and then I press tab. And the command line has this thing called tab complete, where if there's something that matches what you're saying, it'll just complete it for you. So I didn't actually have to type out that full name. I'm going to cancel that for a second because I want to show you one other thing. So I'm in this folder on my computer. So here's this example folder. That's where I'm at right now. If I want to see what's in that folder in the command line, I can say ls, which is list. And it's going to give me a list of everything that's in there. Right now, I just have one folder in this folder. So that's where I'm at. So if I want to go into that folder, I say cd, change directory, space. I start saying EX because that's the name that I'm seeing here as the name of my repository. And I do tab to complete it. That way I don't have to type it myself. And I press enter. And you'll see that now these things are the same, but you're going to see this little location on my terminal is different. Now I'm inside one level deeper. So now I've gone on my file system from here. I've changed directories. I'm here now. So if I do an ls list enter, it's going to list the files that are in there. And what I see is 2 files listed. Again, it's hiding that .git because that's a hidden file. It doesn't need to tell you about that unless you ask. So all I was trying to do, cd to get into that repository. Now let's try git status again. Git space status. This is our first command. And we say git status, and it's going to tell us what's up. And so it's telling us we're on the main branch. It's saying your branch is up to date with the main, so that the origin main is referring to the version that's up on GitHub or wherever else you have it, but on this case, GitHub. And it's saying nothing to commit, working tree clean. That's meaning nothing is different. We haven't changed anything in this repository from the history. It knows what the history says it should be. The folder of files is still exactly the same as what's stored in the history. So there's nothing going on. So what we're going to want to do is change something in our repository. So I'm going to do that by editing one of these files. So you're going to need a text editor on your computer. You most likely have one. And I'm going to use just text editor on Linux. On Mac, you can use TextEdit. On Windows, you can use Notepad or Notepad++ or Visual Studio Code, whatever you want to use. So I just want to open that. So this is in my folder over here, just a regular folder of files. Any piece of software that you regularly use to edit text files is what you can use to edit these files. They're not magic. I'm going to open it with the text editor. My example.md, and you can see that that's the file that was there. At the end of that file, I'm just going to add some new information. So I'm going to put another space, new line added here, space, or line break. Now, in this editor, I'm going to save it, just like a regular, this is a regular file on my computer. I need to save it. There's not committing here, we're just saving. Control S in this case, however you want to save it. And then I'm just going to close that text editor because I don't really need it open anymore. But I know that I've made a change in this repository now. So hopefully you've opened it with some file with a text editor. You've made some kind of change. You could open it with Visual Studio Code. I like to open it with the whole repository at once with Visual Studio Code. If you were using that, but whatever kind of text editor you want to use, probably just go with something simple right now. So Notepad. So let's pop back to that terminal that we left open here, and we want to check that git status again to see what the deal is. And I could just type out git status again, but a quick way, a shortcut on the terminal is that you can click up arrow, and that'll refill your last thing that you said in your history. So my last command that I gave was git status. If I click up arrow again, I get to ls. If I click up arrow again, that was my CD. So you can go through your history by clicking up arrow. So that's just a quick way to do git status.
Let's get in this thing.
Oh, yeah. So you're in PowerShell right now. You need to be in Git Bash instead. So I'll show you. So this one we're just going to close. And this is your Git Bash here. But we can close that. Let's go to where that repository is on your file system. So on this one, you're going to two-finger click. And then we're going to open. You have to show more options. Open Git Bash. Open Git Bash here. So it's kind of hidden away. And that's the one that's going to work.
Oh, but it's working as well. Me, Windows
it is?
PowerShell.
Yeah, so you must have change the install options to make it work on PowerShell, I would suggest using git bash because it'll you're going to end up running into problems eventually on PowerShell. So, okay, does that make sense? Okay. So we had some Windows 11 like hides the open and git bash in a second level of the right click menu. And so we had a few people working in PowerShell on Windows, which sort of worked, but then some people were getting errors already. And if you installed Git for Windows, and then there's one option where you can check it to be like experimental support in Windows terminal or something. And so it was working for one person, not working for the other person. But in the long run, you're probably going to end up with errors eventually. So I would suggest on Windows working with git bash if you're going to work on the command line with Git. And so the thing that was happening on Windows is when you went in here to right click, open in terminal, it hides open and git bash in a second level of options. So there was a spot where you could say more options, and you had to click more options, and then it shows you open git bash here. So just if you're on Windows 11, it's going to be a little bit more navigation to use that shortcut. All right. So we did a get status, and we did it by doing arrow up to quickly get to our last command, and then press enter. And I get a get status now, and it's saying kind of similar. We're on the main branch. The branch is up to date with origin main, which is that one on GitHub. And it says there's changes that are not staged for commit. So that means Git knows we did something. It's tracking what we did. It is not part of the history yet. It says no changes are added to commit. And so we've saved a file. Saving is totally different than committing a file. To actually put this into our history, we actually have to add and then commit. So it's a two-step process. But Git knows something changed. So that's our first step. So if I look at my little diagram here, this working directory is our folder of files. We can do whatever we want with that. It's a normal folder of files. We save files in there. So we can save them to the file system. They're changed. Now we want to take what we've done locally and we want to get that in the history. And so to start that is a process called git add. So what we're going to do is I did my get status. It told me that there's something changed. And then we're going to give the command git add space. And then you can give a file name if you want to just add one file. So we're going to say example.md. I used my tab complete, so I didn't have to write that out. So I did git add ex, and then I said tab, and it figured out the correct file name for me. And then to add that, I'm going to press enter. So you can either give a list of file names. There's also a shortcut where you just say git add all if you just want to add all the things. But normally you can kind of add, it tends to be a commit is kind of topical. You don't want to make like 300 edits and then just commit all those things at the same time. You want to put together a group of related changes at one point in time. So it doesn't always have to be a one-to-one edit. You can add multiple files, but it also typically you want to make it sort of topical so that it makes sense for your history in the future. Is you want to git add a set of files that that you want to make those changes at one point together. So I did a git add example. Now if I do a git status again, I'm going to see slightly different. Main branch, up to date. And now it says there's some changes to be committed. And so what we've done is we've staged that one file. So we've taken this working directory, we used git add to add those changes into the staging area. We haven't committed it yet. It's not in the history yet, but we've prepped it so we could add more files or remove files so we can make that little group of things that we want to commit into our message, into our commit message. So now the last step, we've made a change in the file system. We did a git add. Now we're going to do a git commit, which is what we did when we were editing on GitHub, right? So we're going to say git space commit. space. And when we do a commit, it's going to record automatically the changes. It's going to record automatically the time. It's going to record automatically who did it because you configured that. But we do need to give it a message. And so how you do that is you do -m for message, space, and put a quote sign, and then type a message. So first local commit, and then quote sign to close that quote. And then, sorry. And then you're going to press return to make that commit. So this is like that little form that we did online on GitHub, only it's right here on our local machine on the command line. So it's getting automatically the person, it's getting automatically the time, the changes, and we have to manually give it that message. So git commit space -m for message, quote sign, whatever your message is, quote, to end that, and press enter. And it's going to give you some feedback that you did something, and you made a quote or you made a commit. So if we do a git status now, we'll see where we're at. What you're going to see is it's saying our branch is ahead of GitHub by 1 commit. And it's giving us some helpful advice. It says use git push to publish those changes up to the remote. So if I go over to GitHub right now just to prove this, and I refresh that page, you know, those changes are not here. This this commit message is not there. So we haven't, this is local first. We've done the work locally. We haven't put it up onto the remote. So what we're going to do is we're going to add a new file. So we're just going to repeat this process over again. This time I'm just going to do it on the command line just as a quick way of doing it. So if you're on your terminal here, we're going to say, this is in the outline here, but we can do echo, which just means repeat. And we're going to write some stuff. This will be a line, and quote to close that off, and space. And then you want to do a greater than sign, or caret as we call it on the command line usually. So greater than sign, space. And what that's saying is we're going to take this, whatever this, the output of this command, which is just going to be repeat this line, and we're going to put it into a file. And so we're going to call this one, we got to give it a file name. So I'm going to call it new-file.txt. So we just give it a new file name. And then press enter. And so we're going to take this command. It's going to, caret means put it into this file, whatever that file name is. And you press enter. If I go look at my folder, you're going to see that new file appeared, which is kind of cool. If we do an ls, we can see that new file is there. This is just a quick way in our example to be able to add some new content. And if we do a git status, Git knows that there's something happened. We're on the main branch. We're ahead of the origin by 1. And we also have a new untracked file that's not anywhere in the history yet. So that's important. But let's go ahead and also, I just want to show you nano on the command line too. This is also, again, just a little quick thing so we can just do some work on the command line. Let's do nano. And then my file is, I'm going to open the example file. So I said EX, and then I tab completed it. And if I click enter, it's going to open a little text editor right here in my terminal. So I can go down this text editor. I'm just pressing down arrow, and I'm just going to add another new line. Type some random stuff. On Nano, if we want to save this file, we do Control X. So if you got Nano open, you wrote some new content in that file. This is just a text editor, not related to Git. And we're going to Control X to save it. And it says, do you want to save it? And you're going to say yes. It's going to say file name to write, and you just press enter, and it'll just do, it'll just save it. Yeah.
That cat was on it.
Oh, okay. You're good. So you just use your arrow key to go down here, and then that's you writing. So I'll just show that one more time with folks. I did nano and the file name. And again, this is, don't get distracted by nano. This is just a way to write in a little text editor on the command line. The main reason I want to show you this is because if we get accidentally, if you don't give a message when you're committing, you'll end up opening nano like this, and you'll have to give your message here in nano. If you merge something and there's some, when you git pull, sometimes it'll automatically open nano and you'll have to give a message there. So this is something that you'll probably have to know. So you just edit, add something, text editor. To get out of here, we do Control X, and you want to save it, yes. And then we just press enter to save it. So now if I look in here, that's not going to see anything different. We just edited a file. If I do a get status, we're now going to see something different. We are on the main. We're ahead by 1 commit. There's changes to a file that are currently tracked. So example.md is changed, and there's a new file, txt. So what we're going to do, we made some changes. These are good changes that we want to store in our history. Maybe we're experimenting. Hey, this worked out all right. This is good. We want to store it in our history. So what would be the first step to start storing it in our history? Git add. So we're going to do a git add. And we could say the individual file names, or we can do a -A to add all. I think we have this all somewhere here. Yep. Okay. So git capital or -A means add all of the things that are changed to this commit. So that's just a shortcut. If for some reason we only wanted to commit example.md and not new file, that's where we would just write the file name individually rather than all of them. But in this case, I'm going to do -A because I want to add all of them. Now I could check the status on that just for kicks. It says that there's 2 things that are staged, ready to be committed. We're going to have to commit to actually store them, but we've staged them. So we have a modified file and we have a brand new file. And so the next step is to git commit. Git commit -M for message, quote for the message, add new file and edit. Quote to close that, and then enter to make that commit. Gives me some message about what happened. And if I get status that, it says you're ahead by 2 commits, suggesting we could use get push to push it up, and nothing to commit, which means we haven't made any changes since last time we committed.
I have maybe a Mac question.
Yeah.
So for every time I did ask for status, it said there's this untracked file DS store.
Oh,
I was just
okay.
ignoring it, but now since I said commit like at all,
That's okay.
is that
Yeah. So there's a Mac question that came up. Mac generates these little files called ds_store, which is like a micro database that's about information about the folder. It should actually be ignored by there's a file called git ignore, which tells Git that it should just ignore some things that aren't important. It should be something that's git ignored globally, but apparently in this particular setup, it didn't get set to your global. If you committed it, that's totally fine.
Okay.
Just ignore it.
Okay.
And then in a normal case, we'll try to get that into your global git ignore, but you can also create a git ignore on your local repository, which is something that we commonly do. But we'll talk about that a bit later. So you should have a git status that's like that you're on main, you're ahead by 2, and there's nothing to commit. So on our little thing here. We made some edits in the working directory. We added them to the staging area. We committed them to our local history. But again, it's local first. This is only on our local. It is not on GitHub. So the last piece of this puzzle that we want is to take these things that we did locally, put them up onto the web so that we can collaborate with other people, collaborate with ourselves. So that command is going to be git push. And the full command would be, we would say, I'll show you here, I think. Let's see if I wrote it down here. Okay, git push. So the full command you're going to see would be, we know that this is it's saying origin main. So origin means the remote on GitHub, and main is the branch that we're currently in. So what you're technically supposed to say is origin main, git push origin main. So push it up to the remote into the main branch. We can just actually say git push as a shortcut, since we don't have anything fancy to do. We're not going to push it to some other location and some other branch. So what you're just going to say is git push and then enter. And you see it gives you some information. It's taking that history. It's not actually sending the whole file up. It's just sending the updates to this database in the .git, and it's sending it up to GitHub. And so it's actually very efficient for bandwidth. So if we refresh our GitHub page, I now have the 3 files. I can go over to this thing where it says commits here to take a look at the history. And we now have these 2 commits that we made locally up here on GitHub. And so we can actually go ahead and view visually what those diffs are. We added some new lines, added a whole new file. And so that's that final step on our little workflow here, where we took this history and git push, pushed it up onto our remote, onto GitHub. And so that is the workflow, and 99.9% of what you would do is that. There's not too much more to it. There's a whole lot of really advanced and weird commands that you can get involved in, but in your everyday life, you probably would never need them. So we do a git status. We do, when I'm starting work for the day, if I'm collaborating with someone, I want to make sure I have the most recent code. So I do a git pull, which means grab the stuff from GitHub and bring it down to your local history and refresh your local directory. Everything's up to date. I might make some edits. I'm going to do the git add. I'm going to do the git commit. And then I'm going to do git push at the end of the day or throughout the day, depending on if I'm collaborating with people. And so those are the basic commands that you're going to use over and over and over again. Now, the exciting stuff, once you start doing that, is being able to look at the history, look at these diffs, checking out new branches, and playing with it. And so that's where the real power is. And we're not going to be able to get into that today, because I think we're kind of about full with our brains and out of our time today. But I do have these videos available already on that outline, so you can go ahead and take a look at that. But maybe what I'll do is really quickly explain the branching as a preview of where you want to get to, why this is cool, and then I'll just walk through it really quick to show you kind of what that ends up looking like. Branching is, well, so first I'll just say git history. You can do it on the command line. There's some important things about it, but generally the best place to visualize git history is to use GitHub, where you can look at these commits and you can look at these insights to get a sense of that history. The branching is something that's really great. This is a fundamental idea in Git, is that we can open up a branch of this repository, meaning that we're going to make a copy that is a copy of the history that we can start working on, that's separate from the main branch history, so that we can go back and forth between them. And so what I'm going to show you is doing that. And so the command is git checkout -b for branch, and then we're going to give it a branch name. So a lot of times you name it after a new feature or some topic, or sometimes there's conventions in your project about how you name the branches. So I'm just going to say example branch like everything else today. Don't put any spaces or anything weird in that, lowercase usually. And then I press enter. I'm now on a new branch. If I do a git status, the only thing I'm going to see different is that it says I'm on the branch, example branch. I'm not on the main branch anymore. Now, if I go over here in my folder, I'm going to open it with Visual Studio Code so that I can start messing around with it. So this is my text editor, same thing. I'm just looking at these 3 files. I'm going to go here and I'm going to edit it. And I'm going to save that. I'm going to create a new file in here called new branch file.md. And I'm going to save that. Okay, so now over here on my terminal, I would do a git add. I'm going to do -A for git add all, git commit, -m for message. And I'm going to say adding a new demo file, enter. Okay, I'm on this branch. I did this stuff. We can even do another thing. We could create another file. So I'm just doing this really quick as a demo for you folks. And save it. And then I'm going to do a git add all, git commit, message. And I could do a git status to see what's up. Okay, I'm on the example branch, nothing to commit. The working tree is clean. So now I can look at this closely. Here's my folder of files, right? And I'm going to pull my terminal over here a little bit. And so we got those new files that I just created, right? Well, what happens if I go back to the main branch? So git checkout main means I want to pop back over to the main branch. We didn't create any of those files in the main branch, right? And so they went away. My local file system, those files disappeared. They didn't go away forever. We can always jump back to git checkout example branch. They're there. So this is where it gets really powerful and cool, right? We can have these separate parallel branches where we're doing different things, trying out different stuff. And then if it's good, we can merge them back into our main. So you can see now we have all of these files in my example branch. And I'm going to do a git checkout main. Okay, now I'm here in the main. I only have 3 files again. And I'm going to git merge example branch, enter. And now in my main branch, it pulled in all of this stuff that was in that other branch and brought it into my main branch. And now if I do a git push, that's going to send that whole history up onto GitHub. So we're going to see on GitHub now, have all that stuff going on. All right, chat. All right. So that's where it gets really powerful, really interesting, where now if I'm working with you and we both are working on some new features that are in slightly different parts of our project, I can create a branch and I'm like adding the new page about dogs, and you create a branch that's like reorganizing the navigation, and we work in parallel and we all merge it back down together in the end. So it gets really interesting, really powerful in that way. And so that's really where you want to get to, being able to do some of that. And that's the part that makes the collaboration very, very powerful. And that was actually the first way that I started using Git, because I had a bunch of USB sticks that had all my notes in plain text files, and I would try to sync them between all my computers, and then they would get out of whack. And I was like, I have like almost the same notes, but they're slightly different, and I don't want to lose any of it. And I actually made a Git repository of my home computer version, and then I merged in my notes from work to sort out which ones were supposed to be there and which ones were supposed to be gone. So you can do some really interesting stuff. And so that's what you want to get to. And there's a lot more stuff to learn, but it's that's what's going to be really useful for you. And the last thing I wanted to show before we close up is that we also don't have to do this on the command line. There's a lot of tools that help you do this. So here I am on my Visual Studio Code, which is a text editor, a kind of integrated development environment. I have my representation of this repository. I just opened up this whole repository. It knows that this is a Git repository, so it has features here that help me. Right here, it's telling me what branch I'm on. So I can actually go here and create a new branch, give it a new name. Now I'm on a new branch. I can create a new file with some stuff in it. Save it. And you can see that there's this pane right here on my Visual Studio Code that is a version control pane, and it knows something happened because it's checking in with Git to see it's doing Git status for you essentially. And now it has my changes that have been made. So I've created a new file. Maybe I went over here and I edited another file, saved it. It knows those two changes have happened, just like Git status. I can add them. So here's me doing Git add in my, I click that button instead. Git add, click that button. Now these are staged. I have to make the commit, put a message up here, and I click the blue button to make that commit. All right, now I can go back here, check out my main branch, and I can switch now back to my terminal, and I can do a git merge, whatever that weird branch was called, and I pulled that into my main, and I can do a git push on here. You're using exactly the same tool, whether you're doing it here on this visual version or if you're doing it on that command line. And so why I introduce it on that command line is because it makes it more explicit what you're doing. You're doing this git add, you're doing a git commit, you're doing a git push, and you git pulls. Those are the commands that are going to be given to you by all these visual tools, no matter what one you're doing. So I just use that. I just did a git push by clicking that button, which came up. So the big visual tools that people use is your integrated development environments like this, and then GitHub Desktop is one that GitHub puts out that integrates really nicely with GitHub. GitHub Desktop only does commits and clones and things like that. It's just for using Git. This one is a little bit more different because Visual Studio Code is doing an editor. It's doing a lot of different stuff. We have a terminal in there, and we also have version control built in. So your integrated development environment's got all those things kind of built into one place. But the important thing is just keeping that in mind, that in the end, you're all using the same piece of software underneath. It's doing those same set of things in the workflow. So we're doing working in our directory. We're getting a git add into the staging area. We're git committing it into the history. We take that history and push it up onto GitHub, the remote, using git push. If we edit on GitHub, we want to pull it down to our local using git fetch or git pull, and git pull will actually clean up our working directory to the current version that matches the remote. So that's Git in a nutshell that took 2 hours, and there's more to it. But the thing that I want to reiterate one more time is, you know, it won't make sense unless you just repeat it and start working with it and encounter the possibilities and the challenges that go along with actually using it. So if you have something that actually is meaningful that would make sense to get version controlled, the best way to learn is start doing it, and it'll make a lot more sense when you actually have a reason to use it. There's a lot of resources and guides in here to help you out when you get lost. But my suggestion would be, don't get lost in doing any advanced stuff with Git. You don't need it. I use it every single day, and all I do is add commit and push and pull and branch. So that's Git. the videos are available. I'll make the video of this session today available, and feel free to get in touch with any questions that you have, and we will talk to y'all later. Thank you. Thank you, folks online. I'm gonna stop recording, and we'll talk to y'all later. And give me an email if you have any questions.